Hello, welcome to Drawing the Invisible. This is going to be React explained in 5 visual metaphors. So I'm Maggie. I work on the team at Egghead.io. We're an education website that teaches all varieties of web development. We especially teach a lot of React. So we sometimes joke we're just a React training website, but we do teach all the kinds of web development topics too. I'm the resident art director and lead illustrator there, which in reality is mostly being a metaphor designer. However, my background was in cultural anthropology, so that's kind of the undercurrent of everything I make. I'm very used to looking at the programming world on a cultural and symbolic level. It's a rather odd bundle of jobs. So when I introduce myself at the imaginary cocktail parties that I don't actually attend, I like to say I make illustrations that help explain the invisible abstract world of programming. So just to give you a more tangible sense of what I mean when I say illustrations of programming topics, this is some of my work. These are all course illustrations for topics we teach on Egghead. Every time we put out a course, it gets one of these as the cover, so it's a bit like album artwork for a music record. And when I begin making these, I'm usually handed a course title like Use TypeScript to Develop React Applications. And on the face of it, that doesn't have immediate images spring to mind. So it's then my job to dig around the concepts, understand what they're fundamentally about, and then build up a visual metaphor around them. I also run a little side project called illustrated.dev. And so this is where I draw more illustrated explanations of programming concepts. So if you're a visual learner like I am, I make these for you. For example, I've got one on how APIs are like tiny robo-waiters. And I've got another explaining how GraphQL's query language works. And this one is actually based off a course taught by Eve Pacello, who's presenting a bit later on. And you should make sure you catch her because she's fantastic. So the common theme tying all this work together is that I'm trying to make abstract, invisible, intangible programming stuff visible so that it's easier to understand. In essence, all my work is about making visual metaphors. I find that visual metaphor is an especially powerful tool for explaining and understanding programming because it's already such an abstract discipline. Creating meaningful comparisons can go a really long way when you're trying to help people grasp new programming concepts. However, a very quick disclaimer is that metaphors do not do the same thing that an in-depth code demo will do. That's not really what they're for. So the superpower of metaphors is that it gives us a big picture introduction to things. They're about building storytelling and highlighting specific qualities of otherwise complex concepts, which means that by design, they don't always explain every last detail of how a system works. So I'm not about to do a deep dive into the technical details of React. If you want a nuts and bolts, code and text-based introduction, the whole rest of the internet has you covered. So I'm going to show you my 5 favorite metaphors for the fundamentals of React. I developed these at the very beginning of my React learning journey. My learning process always involves making lots of illustrated notes and building metaphors to wrap my head around concepts. And there was an awful lot to learn. I came to React with minimal JavaScript experience and not a lot of big picture context around how the web development ecosystem works, which was certainly not ideal, but it led to a lot of very entertaining and enlightening misunderstandings. Even if you're here as a grandmaster React expert and you already know all the ins and outs of it, hopefully this will help you to look at it with fresh eyes. It might give you ideas about how to explain it to others as well. So one of my first challenges was figuring out what the big picture physical landscape of a React app looked like. Because my first question was, where are we? As in, like, where in time and space is this React event happening? Are we in the cloud? Are we on my desktop? What's this thing connected to? So this is my first pass at it. I was figuring out where React sits in relationships to the backend servers and to the DOM. And our React zone in the middle here is where React takes in information and data from our all-knowing gods in the clouds and mixes it with our app's logic, and then it creates its own version of what it thinks the DOM should look like, essentially a tree of UI elements, and then it sends that version to the actual DOM, which is then what the user sees. And then when users click buttons or type text, those events are sent back to React, and it gets to react to whatever happened by updating its personal tree of elements. And we go around in a magical loop, right? Even just understanding that data up in the clouds and React and the DOM are all distinct and separate things is one of those huge unspoken assumptions that a lot of beginner courses don't always point out. So I had my map of where React sits in relationship to the rest of the system, but I was still wrapping my head around the visual structure of how a single React file breaks down. So this is where we all start, right? This is the index of a Create React app. This was one of my first stumbling blocks, especially because I didn't already have a lot of experience with JavaScript and web development, but it helped me to break it down into 4 separate parts. So first thing was to realize that there were two kinds of distinct import statements going on. From just looking at the syntax we use, there's no obvious clues that React and React DOM are coming from our node modules folder. I kept trying to figure out where in my folder structure the React and React DOM files were, and there were no clues that I needed to go look in node modules because I assumed their import statements would include the words node modules if so. And then from a very different location, we get all our component files, right? Like header and articles and footer and all the ones that we create ourselves. Learning to unconsciously distinguish between these two is something that we all internalize, and then we immediately forget that we might need to explain it to others. This third chunk in the middle made the most sense. I at least knew this was my domain where I was supposed to actually write and structure my app. And then this last line with React DOM.render was such a confusing mystery, I had to break it apart into its own little illustration. So this is my translation of how I finally figured out what this line was saying. So it's just saying, hey, React DOM, which is an object in the React DOM library, can you please use your render method to render this component onto this part of the DOM? So this was my whole map. It just helped me to internalize the way our React files are organized. So next up was learning what JSX was and how it related to React and JavaScript in the browser, and possibly why I needed to care at all. And since JavaScript isn't fundamentally different to React, but more of an extension off the top of it, it felt right to call it a cherry on top of a vanilla ice cream stack. So we write React, right, in this special flavor of JavaScript called JSX. And I like to imagine that whoever named it called it like X for extreme. And while some parts of JSX can look quite different to JavaScript, it's really just an extension of the language. So we say it adds syntactic sugar on top of JavaScript, which means it looks nice and it's easier to read, right? So it's just the cherry and sprinkles on what is still mostly a JavaScript vanilla ice cream cone. So I like the metaphor vibe going on, but it didn't quite explain enough of the key qualities of JSX that I wanted to get at, so I expanded the metaphor. Since one of the main benefits of writing JSX syntax is that it lets us write markup inside our JavaScript file, I decided we needed to swirl some markup ripple into our vanilla.js cone here. We usually have two separate files, one for JavaScript and one for HTML, that need to link to one another, but with JSX, we can manage our markup and logic side by side in one file. Of course, not everyone likes combining logic and data in one place. There's a long-standing debate about separation of concerns, but also not everyone likes raspberry and chocolate swirled together, but some of us do. And then I learned about Babel, which is a compiler that takes our JSX swirl flavor and turns it into a simpler version of JavaScript that all browsers can read. So all the main browsers like Chrome and Firefox and IE whatever are incredibly picky about their ice cream flavors. They will only accept pure vanilla JavaScript. Not only that, it has to specifically be ES5, which is a slightly older version of JavaScript. So our most up-to-date version right now is ES10. Babel is like an ice cream filtration machine that removes all of that strange markup from our JavaScript and translates it back into plain vanilla JS. So once Babel has made that ice cream palatable for everyone to enjoy, it feeds it into a browser engine, and it runs a whole bunch of complicated systems that I'm not even going to pretend to understand. And eventually it spits out all the DOM elements that our users can see and interact with. So we still get to write our React code in the lovely markup rippled flavor of JSX without being limited by what browsers are going to accept. So now we get to the meat of React with our two leading protagonists, right? Components and props. So when I'm thinking in visual metaphors, I always find it helpful to step back and simplify concepts to their more fundamental categories. So for components, it felt clear to me that this was simply a container. Containers are one of those lovely universal categories of the world. They hold things, they have boundaries, things go into and out of them. So I always draw containers as boxes first. It's an easy thing to draw before you have any better metaphor ideas. And when you're drawing, everything usually starts as a box anyway. So we have our box container, but then we need to add in the UI elements that make up our components. And it felt to me like these were the front face of the component, like the thing our user sees. So I always imagine the elements project off the front of a container. So in my head, the component box is like a tiny box theater with a stage, and the elements are performing on the stage for their audience of users. And the backstage area is where we run logic and set things up and pass it to our on-stage elements. And then we have to add props to this theater scene. And to me, they're clearly a transport system. They carry data into our component. So because perhaps I was in a theatrical mindset and I had some image of, the West End performance of Aladdin in my head, props made the most sense to me as magic carpets carrying that data. I figured components were separated in space and they needed something with flight power to move between them, so we got carpets. So when we add all these theatrical metaphors together, we can see we first set the stage for our component by writing its structure, and then we can reuse that stage design multiple times by simply passing different data into each one using the magical carpet transportation system. It's like having one stage that can host multiple play performances. So I had components and props down, and it was time to add in how they relate to one another and how data moves between them. So initially, I was expecting to draw my component boxes nested inside one another like this, and then have the props flow from the higher components down into the nested components, because that's how they appear in code, right? Both in our code files and in the UI, it's things inside of other things. It's logical they would be nested. But then you learn that components live in a hierarchical tree structure. So I had, okay, parent components, and they pass their data down to child components like this. So it is better to imagine them as separate objects above and below one another, and then props flow from the parents to the children. But I want to focus on this tree idea for a minute, because it's a really good example of how much our metaphorical understanding of a system can influence how we think the code is going to work. So this React component tree idea initially tripped me up, because obviously I drew it like this. It's a tree. It goes upwards. And then I learned about the principle in React that data only flows one way, downwards. So if I pass a prop to this footer, and I need it to end up in this child component, how's that going to work? So things were not adding up, but then I started looking around at diagrams that other people were drawing of their React component trees, and I realized that everyone else had their trees upside down. So that explained a lot of my confusion, which, okay, fine, it's not a huge problem, but it's a little bit weird and counterintuitive. So in my head, rather than use trees, I think it makes much more sense to just turn it into a potato plant. So I liked this. I really started fleshing it out more. So we have our potato components, and they're connected to the props root network. And then data is water that flows down the plant into all our component potatoes. And we can even explain how React's events work in React through this metaphor. So events are like nutrients that move up the plant, because in React, events go up, at least most of the time. So let's say we have a button that's down here, and it's an add button, and it's connected to a potato counter that adds potatoes every time we click it. And our button has an onClick event that calls an add handler function. But that add handler function isn't inside this button component. So if our user clicks on add, we go up the tree into nav, but we find that the function isn't there. So we go up into app, and that's where we find our function declaration. And then when we execute this function, it calls setCount, and that adds 1 to our count variable. And so now we have this piece of count data that has been updated, and it's now a drop of water. And it's being rendered down here in a paragraph element, which currently shows we have 3 potatoes in our counter. So it passes that data down the plant, and then it updates our count to become 4. Okay, so on to metaphor 5. The confusion around props versus state is a very common one among React beginners, and I found thinking in spaceship fleets led by commanders really helped me with this one. So our components have now transformed from potatoes into spaceships, and they're flying in formation in our classic upside-down tree-shaped structure. Just like any good forward-thinking team, this fleet has a distributed system of leadership. So some ships have their own commander inside them, and this is our state commander. Each commander is responsible for a piece of state data. The data might be a true-false boolean, or it might be a numeric amount like a counter, and the commanders are in charge of keeping track of that state data and updating it when they need to. So if any of the props in their child components need to change based on that state data, the commander sends a message to those children to update their props. So let's watch how this might play out in action. Let's say this player component in the middle owns a piece of state data, and it's a variable called isPlaying. And it controls a little music player that shows images while it plays space tunes. So the current state is equal to false, and the play button is pause. Oh, and the pause button is highlighted. And the state of the isPlaying variable is currently false, but if it changes to true, which might happen if the user clicked the play button, then the commander sends a message down to its child components. They need to update their props. So the image knows to change its display, and the play button knows to highlight, and the pause button knows to fade. So the main difference is that state is data that lives inside a particular component, and props are data that live outside the components and are passed in. So obviously we want to make sure that we don't have multiple commanders trying to control the same state data, They might end up sending conflicting messages to their children, and then we'll end up in some horrendous power struggle and where no one knows who to listen to. We only need to add components into our app if the data also needs to change after they launch. And by launch, I just mean that the components have rendered to the DOM. So when you're writing React in a code editor, that's a bit like pre-launch, that the flight mission has not yet begun. But then there's this moment where you run npm run or yarn start, and your ships launch to the DOM, and having a commander in charge of a piece of state is the only way to make changes to your app's data after that point. So we've been through our 5 React metaphors, which were hopefully entertaining. But even if none of that React information was new to you, I hope you at least learned something about thinking in visual metaphors, because actually this entire talk is kind of a ruse. It's not about React at all. It's just about visual metaphors. So the whole thing with the potatoes was kind of an elaborate excuse. I really just wanted to stand on a soapbox for a moment and talk to you about visual metaphors and why I think that the programming community desperately needs them. So here's the problem. Programming, documentation, and tutorials are all walls of text. We are drowning in long written explanations that are only willing to state things in official jargon-laden terms. They're a slog to get through, so most of us don't. There's a reason that read the docs has become a bit of a judgmental reprimand on Twitter. Perhaps we should be thinking more about why the docs are so hard to read. So documentation and tutorials are usually a visual desert. You see very few diagrams, you see even fewer animations or illustrations. Almost nothing is explained through metaphor or analogy. It's seen as too playful or too imprecise or too unprofessional. However, I am not the only visual learner in this virtual room. There are many others like me, and when they are faced with walls of text in documentation and in blog posts that don't include any relatable comparisons, they get a bit sad and lost. Obviously, this isn't the fault of the developers writing documentation and tutorials. That job is already hard, and making metaphors and visually representing them isn't a skill that most developers have cultivated. However, we're also aware there's a slight diversity problem in the React and greater web development community. And I don't just mean race and socioeconomic status and gender. I think the way web development is currently explained and taught limits what kinds of thinkers and creators can join this community. Demystifying the discipline is going to be a huge part of fixing that. While web development has become much more inclusive lately, I think that our learning materials and explanations are still lagging behind. And I think metaphor can help. It gives us bigger picture stories that newer programmers can relate to, and when they're framed in familiar everyday terms like food and plants and physical objects, it creates more accessible entry points into this fortress. Now, quickly, because I'm really trying to sell you on the metaphors, I just want to make sure we're all on the same page about what metaphor is. So a very basic definition is that it's when we understand one thing in terms of another. So here we have thing A that we understand, and thing B, which we don't. In order to help us understand thing B and get a general idea of what it's like and what it can do, we map the qualities of thing A onto it. In the academic study of metaphors, they call thing A the source and thing B the target. So we source qualities from thing A and target them at thing B. I personally like to think of it as the source like a window frame. So we look through it and it frames the way we see our target concept. Something that would otherwise be foreign and abstract suddenly has familiar aspects to it that we can latch onto. This is essentially the human mind doing what it does best. It's pattern matching to adapt to an unfamiliar situation. And just like a window frame, the source frame also gives us a limited view of the world. So anything outside the frame, so qualities that the source and the target do not share, those get hidden, while qualities they do share inside the frame are highlighted. Once we understand the system, we can strategically pick our metaphors depending on what qualities we want to highlight or hide. It allows us to focus on what's important and downplay any irrelevant details. So I'm sure a few people are thinking, aren't metaphors just a frivolous distraction, right? Like, why would I want to pollute my pure mathematical programming concepts with these fuzzy, misleading stories that are completely unrelated? So the sort of fanciful poetic metaphor that you're imagining is a very specific kind of metaphor known as figurative. And this is the type that appears in film and poetry and literature and mythology. It's your classic creative off-the-wall concepts like React as a potato plant. And you're absolutely right that it's very easy to let figurative metaphor get out of hand, to the point where it's often more confusing than helpful. But there is a way to be strategic about how we make figurative metaphors. Good figurative metaphor is based on a much deeper set of metaphorical structures. These are known as cognitive or conceptual metaphors. They're called cognitive because it's a metaphorical system that structures our entire way of thinking about the world. Our whole cognitive world is based on it. These metaphors are the basis of almost all human thought. This theory of cognitive metaphor was first presented by George Lakoff and Mark Johnson in their 1980 book, Metaphors We Live By. You may have heard of this book. It's been enormously influential in linguistic and cognitive studies ever since. Their main argument was that we all use metaphor all day, every day, in just our normal ways of thinking and acting in the world. Everything we say and perceive and do is built around a set of metaphorical frames. And we can see this in language. For example, we often speak about time in terms of money. So we say, I spent 3 hours refactoring that component, but it will save us weeks of debugging later on. Or we've invested a lot of time in this feature, but I'm not sure it's worth the cost. When you start looking for these invisible metaphors, you'll suddenly find that they're everywhere. This is powerful because it points out that all abstract thinking is built off of metaphor. We have all these non-physical things we need to communicate to each other, like emotions and thoughts and ideas and programming concepts. And in order to talk about them, we have to use language that is based in the physical world around us. To give you a few more examples, we associate being happy with the direction up. So we say, things are looking up. I'm in high spirits. I'm on cloud 9. We also talk about ideas in terms of light when we say that that's a really bright idea. It really illuminates the problem. We can also say, I found your talk moving. It really touched me. Or let's go get deep into code. So all of those physical expressions are based on our bodies. As humans, our bodies are our primary way of interacting with the world. So it's a logical starting point for building these metaphors. It gives us a shared visual language with every other human, right? They immediately have that same reference point. I like to think of these as ingredients to build metaphors with, so we can explain our programming concepts through all the elements of physical space, right? Up, down, left, right, in, out, front, behind. And we can also use what we perceive through our 5 senses. So light, heavy, rough, smooth, warm, cold, big, small. And then we're able to build more complex metaphors off of this base. How we speak about and use the internet and computers is a perfect example of all of this. So our interactions with computers are all based in physical metaphors. We think the internet is above us, right? It's up in the cloud, and we're sitting below it. So we upload and download files from it. Its clear websites are locations. We visit them. We've all been to the React Docs page. Past pages are to the left, and future pages are to the right, and they flow through our screens in time and space. So we unconsciously know all of this, but we rarely draw attention to it. And of course, this applies to programming. The reality of what we're doing when we fire up our React app is we're making a bunch of tiny electrical impulses fire in a microscopic piece of hardware that we can't see. So we require an elaborate metaphorical system to do any programming at all. We're just moving imaginary objects around in the imaginary world of JavaScript. So this also shows up in the way we speak. We say React has a hierarchical order to components, right? They're layers of imagined objects. It says we pass data downwards, so it has direction. We have hot reloading in our React apps. We get frustrated when our pages freeze. If our code base gets dirty, we have to clean it up. So the TLDR is that you're already a metaphor maker, which is great news because it means you can use that system of shared cognitive metaphor to help explain tools like React and web development in general to people in a language they already understand. And visuals are one of the best ways to communicate those fundamental metaphors. Since visuals are all about creating representations of the physical world around us, there's no better tool. Words can be a little bit lossy, and when you have to make a diagram or a drawing, you can't be vague about the relationship between the elements in your image. Especially when you want to expand the metaphor into specific comparisons to real-world things like, let's say, plumbing pipe systems or kitchen equipment, then you're able to communicate both spatial relationships and key qualities much faster than you would with a giant block of text. So now I've sold you on the metaphors, and here's my humble request. I would like to see the programming community make content that is both more visual and more metaphorical. If you are someone who writes blog posts or makes tutorials or contributes to documentation, or if you want to be one of those people, I want you to find ways to add visuals and metaphors into your work. This could be making diagrams and contributing them to open source projects. It could be drawing sketches into your next blog post and Any quality level is acceptable as long as it explains the idea. Or it could be making and sharing educational animations with GIFs or a combination of CSS and SVG. Let's just make sure that we're rolling out the welcome mat when people need an introduction to a certain feature of React. Give people familiar concepts and a little bit of storytelling and they'll get hooked. And we can always dive right into code examples afterwards, but we don't always need to lead with the textbook version. Okay, so I already know what you're thinking, right? Like I can't draw. But the good news is it's not just about drawing. So there are plenty of other mediums on offer. You can make diagrams, you can take photos or use stock photography, you can use icons and emoji to build little visual stories, you can make animations, or even just sketching at the level of simple stick figures and with boxes and arrows can still lead to plenty of meaningful visual metaphor. There are also lots of wonderful tools available to help you do this. I personally draw all my work on an iPad with Procreate, but there are a lot of tools that don't require iPads. Apps like Figma and Miro and Whimsical and Excalibur are all free. They will help you create diagrams and visuals with basic vector shapes. Apps like Keynote and PowerPoint are amazing tools for making animations. And then, of course, there's all our native web tools like CSS and SVG, and for more advanced animations, GreenSock. And then we all know there's too many React animation libraries for me to even start mentioning them, right? And for those who do want to go the drawing route, I have a whole page of resources up on illustrator.dev/resources that has all my favorite books and courses on how to learn the basics of illustration. But I'm imagining some of you are still wondering, like, how exactly are we supposed to come up with these metaphors? Okay, that's actually a very good question, right? Metaphor design is not always intuitive, and doing it does require a bit of a tactical approach. So I want to give you a bit of insight into how I develop my metaphors. So this is going to be a very quick cheat sheet going through my step-by-step process. So first, identify the nouns and verbs that you need to build your metaphor around. So this is like laying out the ingredients for what you need to explain. These are going to be the literal things and actions. So with our React potato plant, the nouns were components, props, data, and events. And the verbs were passing data downwards, passing events up, running a function, updating data. And this just helps you get clear on what you need to explain. Second, state what you need to explain in simple high-level terms. So we want to look out for ways to frame it in those physical common properties we talked about. So when we say components are containers, that's a great starting point because a container is one of those higher level categories that any human with a body who lives in the physical world can understand. Third, focus on the key functions and qualities you want to highlight in your concept. When we decide to design a metaphor for something, we're not going to try and explain everything about it. We need to pick what's important and focus on amplifying that using the metaphor. So if we look back at our JSX world ice cream cone, the point here was to communicate that JSX combines markup and JavaScript. Nowhere in this visual are we going to try and explain the inner workings of Babel's compiler system. That's not the point of it. So the metaphor is only about combining two distinct things. So don't try to pack too many details about the system into your metaphor. Fourth, we need to find interesting metaphors that you'll need to think laterally. So fourth, in order to find interesting metaphors, you'll need to think laterally. And lateral thinking simply means thinking sideways into unrelated fields. So using our higher order concepts that we identified earlier, we can find other examples of where they show up in the world. So back with our container component, this could become a vase or a bucket or a bowl or, a spaceship. Anything that acts as a container is a potential metaphor. None of these things are related to the world of React, but they're a common touch point for all the humans in the world who don't know React yet and might want to learn it. And lastly, make sure you add in specific storytelling elements that make your metaphor worth paying attention to. Think of it as a tiny story. You need to hook people with emotion and detail and originality. You all liked this potato plant much more than you would have liked this gray bunch of boxes, even though both demonstrate our hierarchical tree structure. And it's because humans are storytelling creatures. That's our entire evolutionary advantage. We invent absurdly elaborate symbolic worlds, and then we communicate them to each other using stories in order to influence how the other person thinks and behaves. Essentially, you need to speak human and not computer. So just to summarize those, first, find your nouns and verbs. Second, state one main concept in simple terms. Third, pick functions and key qualities to highlight. Fourth, think laterally to find alternatives. And finally, make sure you add in storytelling. So I want to leave you with this quote that beautifully captures what I've been trying to say here. And it's from Tim Roher, who's one of my absolutely favorite thinkers around metaphors and their relationship to programming and machines. And it says, metaphor is just a conduit for the transportation of ideas between minds. So please help transport our wonderful world of React to other people. Now go forth and make metaphors. Thank you.